What's good, YouTube? It's Mr. A, aka Almond with the Sauce. And in today's geometry video, I'm gonna be going over right triangle trigonometry. I'm gonna just tell you what it's about, how it works, and just work out some examples. So get your pencil, get your paper, and let's get into it. Trigonometry. It just sounds hard, I know, right? It's really not that bad though, I promise you. It's really just the study of right triangles. All you're doing is looking at a whole bunch of right triangles and basically like the ratio of all of their sides. That's pretty much what it is. And how it works is like, all right, so you know how like in a right triangle, you'll have a squared, b squared, and c squared. And they usually, you know, do like a Pythagorean theorem problem, and they'll be like, all right, if I give you a and b, can you find c? Or if I give you b and c, can you find a? You know what I'm saying? So usually we're used to seeing right triangles and having like a side or like a leg and a hypotenuse, and you're just finding the other leg. No angles involved, you just plug in the formula, right? So trigonometry is basically, it's kind of the same thing, but usually you're not given both sides. You're only given one side. And the thing that's gonna help you is you're also given an angle. So instead of having two sides and trying to find the third side, you're given one side and an angle, and you got to use those to find the other sides. And that's basically how it works. All right, so basically the first thing to know about trigonometry is you have to know all three sides of the right triangle. Each side has a name. So how it works is you're given a right triangle, and inside this right triangle, remember how I said you're going to be given a side and an angle. Now that angle that you're given is either going to be here or here. It just depends on the problem. And generally that angle is going to be marked by a Greek letter theta. Don't get confused about it. It's no different than saying x. We just use theta whenever we're talking about angles, and that's pretty much it. A lot of people get confused and call it a 0 or a O. It's literally just a letter, and you write it by just doing like an O with a line through it. So basically, all right, so the three sides. The first side I'm going to show you is the side that's always going to be across from your angle theta. So if angle theta is here, the side that's across from that is this orange side, and that is called the opposite side. All right, and so the way you find out what side the opposite side is you just find theta. Whatever side is across from that is always going to be your opposite. All right, the other side we have is called the adjacent side. And if you know, adjacent just means next to. And the way I like to think of it is basically it's the side that's next to theta. All right, but you got to be careful though, because then that brings us to our third side, which is the side that's always across from the right angle. And that side is called the hypotenuse. All right, so those are the three sides: opposite, adjacent, and hypotenuse. You have to be really familiar with where these sides are and how to find them. I'm gonna tell you this. The way you figure out where the opposite is and where the adjacent is always based on where theta is. So I'm gonna do some more examples in a little bit to show you that opposite isn't always like, you'll see some triangles where they're like this, you know, and then theta is right here, so this will be your opposite. And then people think, okay, opposite's always on the bottom, and that's not true. Opposite is literally always across from where theta is. Adjacent is always next to where theta is. Hypotenuse is always across from the right angle. So I'm gonna just draw out some different triangles and then show you how to find each side. All right, so let's look at this example right here. Real quick, I'm just trying to show you what side is opposite, adjacent, and hypotenuse. So again, look at where theta is. Whatever side is across from that is your opposite. All right, here's theta. Whatever side is next to theta but not the hypotenuse is your adjacent. All right, now whichever side is across from the right angle, that's hypotenuse. So really the only way to figure out which one is opposite and which one is adjacent is, again, look at where theta is. And then hypotenuse is always going to be across from the right angle every single time. So I would encourage y'all to just draw some random right triangles of your own, rotate them in a whole bunch of different ways, put theta here, try theta here, and just write out which one is opposite, which one is adjacent, and which one is hypotenuse. Do that like 5 times and you'll be good. All right, so once you've gotten used to figuring out how to find opposite, adjacent, and hypotenuse, it's now time to talk about the 3 what we call trigonometric functions, or people just call them trig functions for short. And just remember, it's a trig function. So at the end of the day, it's still treated just like, you know what I'm saying, f of x equals, let's say 4x plus 2, for example. That's a function, meaning it has an input and it has an output. All right, and that's all a function does. If you remember back in like 6th or 7th or whatever grade, you're taught that a function has an input. You put the input into the function and it produces an output. And that's all the trigonometric functions are. And they are new. They're gonna sound weird, but don't get intimidated by that. Just know they're just functions. They have an input, they have an output. All right, so the first of 3 functions is called the sine function. And it's spelled like this, but you're gonna see it just S-I-N because they like to abbreviate. And the way the function works is like this. Your input is gonna be theta every single time. Theta is always gonna be your input. And then your output is just gonna be a ratio of sides. And that ratio of sides is gonna be your opposite side over your hypotenuse. And that's just how you set up the function. You got your input theta, and then it's gonna be equal to your opposite over hypotenuse. Usually you're gonna be given one side and asked to find the other side. So it'll be like some number over x or x over some number. And we'll get into how to do it in a little bit. So the next function is called the cosine function. And again, when we abbreviate it, it's just gonna be COS, but just like before, the input is always gonna be theta. All right, and then your output is gonna be a ratio of sides again, but this time it's gonna be the adjacent side over the hypotenuse. So if you have a right triangle and the 2 sides you're given are only adjacent and hypotenuse, you know you're gonna use the cosine function in order to solve for your missing side. All right, and then the last function is called the tangent function. And again, its input is theta. And the ratio of sides this time is gonna be, it's weird because you don't involve hypotenuse. So it's actually just gonna be opposite over adjacent. So those are the 3 trig functions that you're gonna use whenever you're doing a trigonometry problem. If you can remember this, and if you can remember how to identify opposite, adjacent, and hypotenuse, that's basically all trig is. So one trick a lot of people like to teach is just to know that the sine is the opposite over hypotenuse, the cosine is adjacent over hypotenuse, and then the tangent is opposite over adjacent. So a lot of people like to teach SOHCAHTOA. I always encourage students to, just come up with something on your own that may be catchy to you, you know what I'm saying? Something that's gonna stick. And just remember how to spell it correctly and just know what each letter stands for. And then that's pretty much it. So I'm gonna show you how to do some examples and that'll be it. All right, so let's look at this first example. Pretty easy, we're just solving for x in a right triangle. So depending on, like what videos you look or how your teacher tells you how to do it, or, textbooks might tell you to do it one way. Here's how I like to do it. I like to do it in steps. So the first step is always going to be to just fill out the information about the 3 things given to you. Those 3 things are theta and your 2 sides, in this case 5 and x. All right, and then you just fill it in with whatever it is. So theta, our angle is going to be 28 degrees. 5, what part of the triangle is that? And so theta's right here. This is going to be the hypotenuse because it's across from the right angle. And this is the opposite because it's across from theta. So that means that this has to be adjacent. And then like we said, x is across from the right angle, so that makes it the hypotenuse. That's the first step, is just filling this out. And then after that, you're gonna look at what two sides you're dealing with. In this case, we have adjacent and hypotenuse. Depending on which two sides you have, that's gonna dictate whether you use sine, cosine, or tangent. So all you gotta do is just be like, all right, I got hypotenuse and adjacent. Which one of these has an A and an H in it? That's gonna be this one, A and an H. So the C means you're gonna use the cosine function. And so once you figure out which function you're gonna use, all you do is replace everything in this with the stuff from here. So cosine, and then instead of putting theta in parentheses, I'm gonna put 28 degrees. And that's gonna be equal to, what do we say? Adjacent over hypotenuse. So it's gonna be 5 over x. All right, and in my opinion, that's the hardest part right there, just setting it up. Because once you get the setup, all it is just straight up algebra from there. And so what you do is, or what I like to do at least, is I notice on the right side I have a fraction. If I can make the left side have a fraction too, by putting it over 1, and then I can cross multiply. So that's all we're gonna do. 5 times 1 is just 5, of course, equals. Now, I'm gonna tell you this and I'm gonna tell you this again because I see this all the time. When a lot of people cross multiply right here, they just wanna say 28 times x. You can't neglect the fact that there's a cosine right there, because if you think about it, like I said from the beginning of the video, cosine is just a function. So when you take the cosine of 28 degrees as your input, that's gonna give you a specific output, which is far different from 28. If you don't believe me, go on your calculator and type in cosine 28 and just watch how far off that is from actual 28. So I say all that to say, don't just put what's in parentheses, but do the whole entire cosine of 28 times x. All right, so after that, we're trying to get x by itself, like you know, and you just treat it like a regular algebra problem. So if we're trying to get x by itself, you're gonna divide not by 28, but again, by the whole cosine of 28 degrees. And if I do it on the right, of course, I do it on the left. Cosine of 28 degrees. All right, so now you know you have the same thing on top and on bottom. Anything divided by itself is 1, so those are just gonna cancel out. And now x is by itself, which is what we want. And so just by looking at it, you can see x is equal to 5 over the cosine of 28 degrees. And that's literally it. But a lot of times they're gonna ask you to, you know, just give an actual number. And so you're gonna have to use a calculator. That's the only way how to do it. So I'm going to my calculator. If you have anything like what I have, make sure you hit mode and make sure you're in degree mode. Radian mode is a whole different thing. We'll get into that in another video. But all you're gonna do is just type in what you see. 5 divided by, and then I like to put this whole thing in parentheses just to be safe. So I'm gonna type cosine of 28, close parentheses, and then hit equal. And that's my answer. So they might tell you to like round to the nearest 10th, nearest 100th or whatever. So depending on the problem, you know, you'll round it differently, but I'm just gonna go with 5.66. And that's it, you're done. All right, so I'm gonna do some more examples. I'm gonna do some harder ones too, so just stay tuned. All right, so in this next example, we got a word problem. And don't freak out, word problems, it's the same thing as a regular problem, except you just gotta read the problem and figure out how to make the triangle based off of what you read. So it says an observation tower is 75 meters high. So right then and there, I'll go ahead and draw my tower. So that line right there is gonna represent my observation tower, which is 75 meters high. All right, and then it says the support wire is attached to the tower 20 meters from the top. So from the top, this wire is attached 20 meters from the top. So you know the wire goes into the ground like that. And then let's go ahead and draw our ground to complete the triangle. And you already know we're dealing with the right triangle. So we can go ahead and do it like that. And since it's 20 meters from the top, you already know this distance right here is going to be 20 meters. All right, so it says if the support wire and the ground form an angle, so this is the support wire, this is the ground, it forms an angle of 46 degrees. So they're asking, what is the length of the wire? So the wire, we're just going to put an X, since that's what we're trying to find. And so just from the word problem, we just created a triangle, and it just becomes a regular problem. So just like last time, step one, all you got to do is fill out your information. So theta is going to be equal to 46 degrees. And then what do we have? This side of our triangle, which if the whole thing is 75 and we're taking off 20, then that means this part right here is going to be 55. So our 55 meter side is going to act as our opposite because it's across from theta, like we said. And then the X, which is what we're trying to find, is across from the right angle. So that's going to be the hypotenuse. All right, so that was our first step, just defining everything that was given in our triangle. So from there, we know we got an opposite and a hypotenuse. So we look at our functions. Which one has an O and an H? O and an H. So we're going to be using the sine function. So all that means is we're going to rewrite the function, but again, replace theta, opposite, and hypotenuse with these three right here. So it's going to be sine of 46 degrees equals, what does it say? Opposite over hypotenuse. So we're going to go 55 over X. And then that was the hardest part right there, just setting this up. Once you set it up, again, same thing every time. Put it over 1, cross multiply. So 55 times 1 is 55 equals, now again, a lot of people might instinctively put 46x, but remember, it's a whole function, sine of 46. Sine of 46 degrees times x. All right, so we're trying to get x by itself, so all you do is divide by sine of 46 on both sides, calculate it, and then we're done. So, you know, those cancel out. X is by itself, which is what we want. Now all we got to do is calculate. All right, so just like last time, make sure you go to hit mode and make sure you're in degree mode, not radian mode. All right, so what do we have? 55 divided by, 55 divided by sine of 46. And that's gonna give us 76.46 if we round it. And then in this case, it was a word problem and our distances were given to us in meters. So we're gonna give them back an answer in meters. And that's it. All right, so in this last example, we got another word problem. It says a surveyor wishes to find the height of a building. So right then and there, we know we have a building represented by this line and we're trying to find the height of that building. So let's just put an X. All right, he says he measures a distance of 1,500 feet along the ground. So that distance right there is going to be 1,500 feet. And then, of course, that's our right angle. And it says the angle of elevation to the top of the building. So angle of elevation. You know, to elevate means to, you know, rise up. So that's going to be this angle right here. That is our angle of elevation, and it is 24 degrees. All right, how tall is the building? So already we just have a regular problem from the word problem and just repeat the same steps. Theta, and then our two sides are the 1,500 foot side and then X. So theta obviously is 24 degrees. 1,500 feet is next to theta, but it's not the hypotenuse, so that makes it the adjacent side. And then X is across from theta, so that makes it the opposite side. All right, now just looking at this, which trig function are we going to use? Or in other words, which trig function has an O and an A in it. So we just go here, O and an A, we're gonna be using the tangent function. So all you do is rewrite this, again, replace theta, opposite, and adjacent with these three right here. So I'm gonna say the tangent of what? 24 degrees equals opposite over adjacent. So that's gonna be X over 1500. Opposite over adjacent. And then same thing, put it over 1, cross multiply. 1 times X, of course, is X. And then not 1500 times 24, remember, it's the tangent of 24 degrees times 1500. So after we put that in the calculator, we'll be done. So make sure you're in degree mode. And it says we're gonna go tangent of 24 times 1500. All right, so 667.84 feet. And that's it. So I encourage you to, you can go online and look up some other problems. It's basically going to be the same 3 steps every time. Come up with this, figure out which function you're going to use, and then just replace the theta and the 2 sides with your pieces of information, cross multiply and solve every single time. And that's it. All right, so thanks for watching the video. Hopefully it helped. If it did, make sure you leave a thumbs up. If you have any questions or suggestions as to what I should make in the future, make sure you drop a comment below. Make sure to subscribe if you're new and hit that notification bell. And with that being said, I'm out.